Good afternoon, folks, from Philosophy 1150, Basic Logic. So, we're going to move on to Part E of Assignment 11. This is going to be the last part of the last assignment before Test 3, which you will receive in your email at precisely 10 a.m. on Wednesday, April 1st, 6 days from now, and you will be required to return that exam to the Moodle assignment slot. I'll explain a little bit more about that in the email at 1 p.m. So in other words, you will have 3 hours for the exam. You don't really need that long, but I'll give everyone a little bit of extra time just in case there are various kinds of logistical problems. Hopefully, you're beginning to become fairly familiar at an intuitive level with the symbolization and what it stands for. Remember, there are two separate stages, so to speak, in these symbolization operations. The first thing, look at the English sentence and get clear, okay, what exactly is this English sentence committing me to about how the world is? And then the second part, how can I use the terminology, how can I set up a sentence that will exactly specify the complex commitment about the world that's indicated by the English sentence. We start off with sentence 1, part E. Someone is having her cake and eating it too. So there's a two-place predicate, capital HXY, X is having Y. There's a one-place predicate, PX, X is a person, and another one-place predicate, CX, X is a cake, and finally a second two-place relation, EXY, X is eating Y. So, we start off then with the subject of the sentence, someone. There's at least one X such that X is a person. And there's at least one Y such that Y is cake, and then we have our two-place predicates. X is having Y, and X is eating Y. So we can put a second set of square brackets there. Now the last thing to do is close in two of the three conjuncts in the triple conjunction in the square brackets. We could have done it in the first two. Either way is fine. Note, in this particular case, we're not doing it in order to indicate what the quantifier range is over. We're doing it to preserve binary form. Now, one last thing that needs to be put in. So we've got two round brackets, two square brackets, but notice the bracket here that's necessary to indicate that the X bound variable ranges over the whole thing doesn't have a pairing bracket. So we'll put one more bracket in there, and notice now the situation is these two round brackets go together. This square bracket goes with this inner one, and the outer one goes with that outer one. So there's at least one X such that X is a person, and at least one Y such that Y is cake, and X is having Y, and X is eating Y. Someone is having her cake and eating it too. Notice, once again, we've got both existential quantifiers and the only binary sentential indicator we've got is the conjunction. 4, lots of big words here. All metaphysicians, they're just philosophers who study metaphysics, an area of philosophy having to do with different theories about the nature of reality. All metaphysicians, except idealists, postulate or claim that it exists, the existence of at least one corporeal or physical entity. So, MX, X is a metaphysician, IX, X is an idealist, PXY, X posits the existence of Y, and finally CX, X is a corporeal entity. All metaphysicians, except idealists, do something. So, this is a universal with the word all. All X are such that if X is a metaphysician and it's not the case that X is an idealist. So all metaphysicians except idealists postulate the existence of at least one corporeal entity. All X are such that if X is a metaphysician and not an idealist, then there's at least one Y such that Y is corporeal, and is it P for our two-place predicate? Yes, it is. X postulates the existence of Y. So, with this one, we just need a single square bracket. So these two square brackets indicate that the universal quantifier with the x-bound variable ranges over the whole thing. Then the existential quantifier with the y-bound variable ranges over the consequent of the conditional, and the particular overlapping part is right here where X postulates the existence of Y. All X are such that if X is a metaphysician and not an idealist, then there's at least one Y such that Y is corporeal and X postulates the existence of Y. The English sentence that this has to match exactly says, all metaphysicians except idealists postulate the existence of at least one corporeal entity. Okay. We move to 7. Everyone who hates someone hates himself. Okay. So, all X are such that if X is a person, then if there exists at least one Y such that Y is a person and X hates Y, then X hates X. So, here's going to be one of these situations. I just keep running out of room at the end. Maybe I'll make that a little bit neater. Okay. So now these two brackets go together, these two square ones, these two square ones, and the round ones. All x are such that if x is a person, then if there exists a y such that y is a person and x hates y, then x hates x, namely themselves. So once again, the reflexive relation comes up. Everyone who hates someone hates themselves. Okay, question 10. Some planets' moons are Jupiter's moons. So that's a little bit of an unusual English sentence, so think about exactly what that's committing you to. Some planets' moons are Jupiter's moons. And then we have to think about, all right, how are we going to symbolize that using the one-place predicate px, x is a planet. Then we've got a two-place predicate mxy, x is a moon of y, or a two-place relation, sorry, and then we've got the name Jupiter. So notice we don't have a one-place predicate, x is a moon. We just have x is a planet, then we have the two-place relation, x is a moon of y. Don't we need a one-place predicate, x is a moon, to refer to the moons? No, we don't, and I'll show you how this works. Some planets' moons are Jupiter's moons. So, there's at least one x such that x is a planet, and there's at least one y such that y is a moon of x, and y is a moon of Jupiter. So, if we look at the two-place predicate, mxy, x is a moon of y, so, just to remind you, there's nothing requiring that x be used to refer to the moon. Rather, having it set up in such a way that mxy is defined as x is a moon of y tells us that whatever goes in the innermost slot, that's the moon. Whatever goes in the outermost slot, that's the planet, regardless of whether either of those have an x, a y, or a z. So, think about the symbolization and see if you're satisfied that it does indeed exactly specify the underlying logical implications, the commitment about how the world is specified by the English sentence. There's at least one x such that x is a planet, and there's at least one y such that y is a moon of x. So even though we're using the y bound variable, the important thing is we've got it in the inner slot where the moon goes, and we've got the planet in the outer slot. So there's at least one x such that x is a planet, and at least one y such that y is a moon of x, and y is a moon of Jupiter. Does that exactly specify the commitment about the world indicated by the English sentence, some planets' moons are Jupiter's moons? Yes, it does. Okay, now we'll move on to consider, for one final time, some three-place relations. We move on to question 13. So the English sentence for question 13 says, there was a time when nobody lived anywhere. So we've got three one-place predicates, tx, x is a time, rx, x is a person, px, x is a place, and we've also got L16, a three-place relation which is defined as x lived at y during z. So, as you're going to see in just a moment, very worth our while to pause and get crystal clear on what's indicated here. Whatever goes in the innermost slot of this three-place relation is the person. What goes in the middle slot is the place where they lived, and what goes in the outer slot is the time at which the person lived at that place. Okay, that being said, the English sentence says, there was a time when nobody lived anywhere. So the first part of that, fairly straightforward. There's at least one x such that x is a time. And, okay, so what's the next part of the sentence here? There was a time when nobody lived anywhere. So there's at least one x such that x is a time, and it's not the case that there exists a y such that y is a person, and it's not the case that there exists a z such that z is a place. And how does the three-place relation have to go? Given that we've used the x-bound variable to refer to the time, the y-bound variable to refer to the person, the z-bound variable to refer to the place. Well, according to the way the three-place predicate is defined, the inner slot has to go for the person. So that's y. The middle slot has to go for the place, that's z. And the outer slot has to go with the time. So, what we want to put here then is y, z, x. So, then we put brackets around those two. We're also going to need a set of brackets around these two. And finally, a set of brackets to indicate that the existential quantifier with the x-bound variable ranges over the whole thing. So let's read it through one last time and make sure that we understand why the three-place relation has to be yzx, given what we put earlier. There's at least one x such that x is a time, where it's not the case that there exists a y such that y is a person, and it's not the case that there exists a z such that z is a place, and y lives at z during time x. So that's exactly the way we want it to be. That exactly specifies the commitment about how the world is, indicated by the English sentence, there was a time when nobody lived anywhere. We move on to question 16. Fortunately, that gives us a bit of a breather. A rolling stone gathers no moss. So we've got the one-place predicate x rolls, the one-place predicate x is a stone, and the one-place predicate X is moss, and we've got the two-place relation X gathers Y. A rolling stone gathers no moss. So what's being claimed here? A single rolling stone or rolling stones in general? That is to say, every rolling stone. This is something about English. I hope those of you who are learning English as a second language don't find this unduly difficult. What's being claimed here is that rolling stones in general gather no moss. That is to say, all X are such that if X is rolling and X is a stone, then it's not the case that there exists a Y such that Y is moss and X gathers Y. Okay, so not exactly a simple construction, but compared to this guy, a little bit simpler. All X are such that if X is a rolling stone, then it's not the case that there exists a Y such that Y is moss and X gathers Y. Finally, we move to question 19. If anyone is married to anyone, then someone wed them both. So, we've got the one-place predicate person, we've got the two-place relation MXY, X is married to Y, and we've got the three-place relation W, XYZ, X wed Y to Z. So, let's get crystal clear on what's involved here. We've got the two-place relation X is married to Y. This is an example of an unordered relation. Doesn't matter which of the two goes in which slot. They're both just spouses married to each other. When we move to the three-place relation, X weds Y to Z, very important that in the innermost slot we have the ceremony performer. But the two outermost slots don't have to be precisely ordered. We just need the two spouses there. All right, so let's consider the English sentence once again. If anyone is married to anyone, then someone wed them both. All X and all Y are such that if X is a person and Y is a person and X is married to Y, or you could have Y married to X, given that this two-place relation is not ordered. If all those things are so, then there's at least one Z such that Z is a person and Z wed X to Y. So those last two, of course, could go in any order. So we'll put a bracket around those two. Just pretend this little wood part isn't there. These two square brackets are closed, but we do need one more square bracket. So that gives us all X and all Y are such that if X is a person and Y is a person, and X is married to Y, then there's at least one Z such that Z is a person and Z wed or wedded X to Y. Notice We don't have Y and Z for these two, and we don't have X in the innermost slot, because we're using Z to refer to the ceremony performer, and we are using X and Y, as we did in the two-place relation, to refer to the two people married. Okay, so we're going to have the third exam 6 days from now. Do as many of the questions as you can, if not all of them, in assignments 9, 10, and 11. And you should be well prepared for that third exam. After the third exam, we will move on to consider how to construct proofs using this more fine-grained symbolic system.